Right, 4.2, we're talking about angle relationships and triangles, and hopefully by the end of the video today you will be able to find the measures of interior and exterior angles of a triangle, as well as apply theorems about the interior and exterior angles of triangles. So before we begin, there's a lot of theorems in this video. We need to break down some vocabulary. When I'm talking about an interior angle, I'm talking about the inside. So this part is considered the interior, and everything outside is considered the exterior. So interior angles are inside the triangle, and examples would be angle 1, angle 2, and angle 3 in this picture. An exterior angle is supplementary to that interior angle. It's when you extend one of the lines of the triangle, and it's supplementary. Sorry, that's my phone. It's supplementary and to this interior angle, and it's outside the triangle. And example would be angle 4. Remote interior angles. This is important later on, so remind me, and we'll come back to that. Okay, so the first theorem we're going to talk about is one you already know. It's called the triangle sum theorem, and we'll use this in proofs later. Yay. If you have your yellow cheat sheet, I would copy it down on your yellow cheat sheet. We'll do that in class if you remind me. We can do that in class. Basically, the triangle sum theorem, sum means we add, right? So if we add up all the angles in a triangle, so if you add up angle A, angle B, and angle C, and every single triangle that exists in the entire world, they're always going to add up to equal 180 degrees. So if I was going to write a note to myself, I would write all angles add up to be 180 degrees in a triangle. Okay, so first thing you're going to do is we're going to apply that. So for example, for some reason it didn't print out on your worksheet, and I apologize. So you can fill in the blanks. Find measure of angle B. So you're going to have to write that on your paper. And what we're doing is if I give you two angle measures, you're going to add those up. So 80 plus 25 equals 105. So that means these add up to be 105. So this missing angle has got to be something so that 105 plus this angle x equals 180. So you can subtract it from 180, and then let's see, and we're going to have to borrow the 1, so 10 minus 5 is 5, and then 7 minus 0 is 7. So your answer is going to be that measure of angle B is 75 degrees. And if you want to check your work, then you just add them all up, and they should equal 180 degrees. So you're going to try to do number 2, and if you want to get a stamp, you have to have number 2 completed. Number 3 and 4 are just application problems. So for example, after an accident, the positions of cars are measured by law enforcement to investigate the collision, like where they collided and how fast they were going and all that stuff. So it says use the diagram drawn from the information collected to find measure of angle XYZ. XYZ is this angle right here. So in the real world, sometimes we're given way too much information. In this case, we don't need this 12 degrees for anything. We can just look at this triangle. So if we to add up the 62 and the 40, that's 102, and then you subtract it from 180, and so this angle is 78 degrees, and then the police can figure out what happened in the collision afterwards. Okay, so that's triangle sum theorem. Shout out by Miss Kiss. I say, what? Okay, so there's two corollaries to the triangle sum theorem. Corollaries is like a theorem. It just stems from, it's like the baby of the triangle sum theorem. And basically it says if we're talking about a right triangle, let's say, and you know all the angles have to add up to be 180 degrees, right? Well, if it's a right triangle, then you know that one angle is already 90 degrees. So if you take 180 and you subtract 90 degrees from it, that means these other two acute angles have to add up to be 90 degrees. They're complementary. So in a right triangle, there's a shortcut. So I would write the shortcut. If it's a right triangle, excuse me, then just subtract, rather than subtracting it from 180, just subtract the angles from 90 degrees. It's a shortcut, and I'll show you in a second. The other one, when we talked about this in class, the triangle sum theorem, if we're talking about equilateral triangles, or if we're talking about equiangular triangles, equilateral, all the sides are the same, equiangular, all the angles are the same, then if you add up the angles, since the angles have to be congruent, the angles have to equal 60 degrees. So we can use that to help us solve problems. All right, so let's apply that then. Basically, I'll do a harder one with you guys. So you guys are responsible for number 5, and I'll show you how to do it based on number 6. So number 6 is the measure of one of the acute angles, that's important, in a right triangle, that's important, is 48 2/5, that's important. What's the measure of the other acute angle? So if you wanted to draw a picture, we'd have a right triangle, and I know that one of these angles is 48 2/5 degrees. And what's this other one? That I could call that my x, I could call that my question mark, we don't know. Okay, so basically, remember the shortcut that we wrote on our other piece of paper was that they're going to, if it's a right triangle, just subtract it from 90 degrees, rather than adding up all the angles and subtracting it from 180. So how we can do this is we can just say that 90 minus that 48 2/5. And so some people are confused because there's that fraction. Okay, it's just like, let's say it was 48 degrees, okay, and there was no fraction. This other acute angle would be, let's see, 42 degrees, right? Because 42 plus 48 plus 90 equals 180 degrees. So that's why the shortcut is just to subtract it from 90, because these two angles are complementary. Okay, so, but now we have a fraction. So to subtract fractions, excuse me, because we can't use a calculator on the state test, what I'm going to do is I'm going to take this and I'm going to change it into 89 5/5. Because 5/5 is just 1, and 1 plus 89 equals 90. So that works. Minus this 48 2/5. Now the fractions, remember for fractions, you just subtract when the denominator is the same, they're both 5, you just subtract the numerator. So 5 minus 2 is 3/5. And then 89 minus 48, 9 minus 8 is 1, and 8 minus 4 is 4. So your answer, your final answer is 41 3/5 degrees. And that makes sense because it's really close to 42 degrees, which is what we tried. Okay, so that's one type of question I gave you. Again, just subtract it from 90. So another type of question I could give you, a harder type of question, is where I input a variable. So I'm telling you in this one that the acute angles, one of the acute angles in a right triangle is 2x degrees. We don't know anything about this angle. You cannot solve for x. All I want to know is what would this one have to be. This one is just going to be right here. Remember, see how we just subtracted from 90? This one's just going to be 90 minus 2x. And unfortunately, you can't solve. That's all you have to do. That's your final answer. Okay, so you're responsible for doing number 5 if you want to get full points on your notes. And we'll do numbers 8, 9, and 10 in class. Okay, one last one. You guys are doing great. The exterior angle theorem. This is where we're going to go back to the front and talk more about the vocabulary, because remember, our vocabulary said that an interior angle is inside and an exterior angle is outside, and then I left the remote interior angle blank. Now the remote interior angle deals with the exterior angles and some of the interior angles. Now imagine angle 4 is the exterior angle and it has a remote control, because remote kind of sounds like remote control, right? Or a remote island, something far off. We use a remote control to connect to something far away. So angle 4 has a remote control and it's going to remote plug into angle 1 and angle 2. So what that means is if you have a triangle, let's say this is your angle right here. If I wanted to talk about remote interior angles, it's going to be the ones not touching this angle. So the remote interior angles is across from, it is not adjacent to, non-adjacent to the exterior angles. And there's always going to be 2 remote interior angles, because angle number 3 is the only one that does touch angle 4. So angle 1 and angle 2 are exterior angles. So we're going to write angle 1 and angle 2 are exterior to angle 4. Our remote interior angles. Excuse me, that didn't make sense at all. Okay, angle 1 and angle 2 are remote interior angles. Okay, so now we know about that terminology, and that'll help us out with this last theorem. The last theorem says if we take this exterior angle, there's a relationship between that exterior angle and the two remote interior angles, and that is, let's say I give you numbers, so we can actually figure out what the exterior angle theorem is. Okay, let's say I tell you that this angle in a triangle is, let's say it's 80 degrees. That's a nice easy number. Okay, and then let's say this angle is 20 degrees, and clearly it doesn't look like it in my picture, but okay. Well, the triangle sum theorem says that if you add up these two angles, well, that's 100 degrees, and you subtract it from 180 because that's how many degrees are in a triangle, then that leftover angle is going to be 80 degrees. Okay, so now we have 80 degrees here. If we wanted to figure out what that exterior angle is, well, notice that the 80 degrees and this yellow angle are supplementary, right? That's the relationship between the exterior angle and the adjacent interior angle. So if I wanted to figure out what this yellow angle is, I'd just subtract 80 from 180 and I'd get 100 degrees because these two angles add up to be 180 degrees. They make a straight line. Now, what do you notice is true about this exterior angle and the two remote interior angles? Well, they equal each other, and that's what this theorem says, that the exterior angle is going to equal the sum of the two interior angles. So how I would write that, to remind myself, is the exterior angle equals the two remote interior angles. So I'm going to put remote plus interior, and that'll help me remember that there's interior, that there are two remote interior angles, and you're just going to add them up. Okay, so this was an easy example. Obviously, I'm going to make it harder because you guys are smart and I like to challenge you guys. So how I'm going to make it harder is I'm going to put in X's. This is the last problem we're going to do, and you're not responsible. We'll do the rest of these in class tomorrow, so you do not have to do these tonight. Okay, so last one, it says find measure of angle B. That's important. Okay, this is measure of angle B, and here's measure of angle B. So I know that so far, measure of angle B is 2x plus 3 degrees. But again, that doesn't make sense. If you went and bought something for 2x plus $3, people would look at you crazy. So that means we need to first solve for x. This is going to be a multi-step question. Okay, so I have an exterior angle and I have two remote interior angles. Notice how these angles do not touch that red angle, that exterior angle. So that means if my exterior angle is going to equal the two remote interior angles added up. Okay, so my exterior angle is the 5x minus 60. My two remote interior angles are the 15 and the 2x plus 3. And now we're going to solve for x. So 5x minus 60, I'm going to combine like terms, equals 2x plus 18. I'm going to subtract the 2x and move it over. I'm going to get rid of this 60 by adding it. And so now I have what? I think I have, this is what's negative. So I have 3x equals 78. And then I'm going to divide both sides by 3. And let's see, what do I get? X equals 20, let's see, 78 divided by 3, 2, 6, 18, 6. Okay, so X equals 26. And we are not done. Do not do your happy dance because, again, we wanted to find this, 2x plus 3. So the last thing you have to do is plug it in. So if x equals 26, 2 times 26 plus 3, I think this is 52. 52 plus 3 equals 55 degrees. So that means this angle is going to be 55 degrees. If you wanted to check your work, which is always a good idea, well, we know that these two interior angles are now 15 and 55, right? So 15 plus 55 is, let's see, 70 degrees. Let's see, if we plug this into the exterior angle, we should also get 70 degrees. So if you wanted to check, you do 5 times 26, because that's x, minus 60. If it equals 70 degrees, then we did our problem right. If it doesn't, then you did your math wrong. You did your algebra wrong somewhere. All right, so again, you're not responsible for 12, 13, and 14. We'll do that tomorrow in class. And the fun fact of the video, is a tarantula can live for more than 2 years without eating a single thing. That's pretty cool. I don't know about you guys. I think that's pretty cool. All right, yay for all these triangle theorems.